Hello my dear children. Welcome back to the lecture series of aldehydes, ketones and carboxylic acid of Maharashtra Board Grade 12 Chemistry. This is our third video of the same chapter where you are going to cover the preparation method for aldehydes and ketones. My name is 𝐒𝐵𝗵𝗀 and you are watching 𝐶𝐻𝐵 classes. Let's get started. So today we are going to cover preparation of aldehydes and ketones. The first preparation is from alcohols by the method of oxidation. Okay. Now if we have primary alcohol, what is primary alcohol? The primary alcohol has a functional group that is CH2OH. So whenever you see CH2OH, you understand it is primary alcohol. So if we have primary alcohol, this is RCH2OH, that's your primary alcohol, and we oxidize it with PCC. The full form of PCC is pyridinium chlorochromate. Okay, PCC is pyridinium chlorochromate, which is a mild oxidizing agent. Okay, why we are using mild oxidizing agent? Because we know if we use a strong oxidizing agent, primary alcohols directly converts to carboxylic acid. But we don't want them to convert to carboxylic acid. We want to stop the reaction in aldehyde. Okay, so we are using a pyridinium, the mild oxidizing agent, that is pyridinium chlorochromate. So this is our primary alcohol, pyridinium chlorochromate. Oxidation is taking place and CH2OH group, this functional group, is converted to CHO, that is my aldehyde, with the liberation of water. So let us take an example, CH3CH2OH. It is an alcohol with 2 carbon atoms, so it is ethyl alcohol, pyridinium chlorochromate. Oxidation is taking place and CH2OH group will just convert into CHO group. Just remember this much, wherever is CH2OH group, that is going to convert into CHO group. That's all. With pyridinium chlorochromate, rest everything will remain as it is, okay, with the liberation of water. Now if we have secondary alcohol, the functional group is CHOH. So if you see CHOH group, it is a secondary alcohol. We oxidize it with the help of K2Cr2O7 and acid, that is acidified. You can also write it as acidified K2Cr2O7, potassium dichromate, which is a very strong oxidizing agent, whereas this 2 hydrogen will come out and you will be getting ketone group. So remember that CHOH group will convert into CO group on oxidation. I'll just write it here. If it is a CHOH group, on oxidation it is going to convert into CO group, that is ketone group. And if it is CH2OH group, that is primary alcohol, on oxidation will convert into CHO group, that is aldehyde. Okay, these 2 things we need to remember. Take an example. This is CH3CHOH CH3. This is called as isopropyl alcohol. With the help of strong oxidizing agent, acidified K2Cr2O7, oxidation is taking place and it is converted into CH3COCH3. This is called as acetone, or the IUPAC's name is propanone, with the liberation of 1 molecule of water. Now, the second oxidation process is by using copper. This was by using mild oxidizing agent, pyridinium chlorochromate, and a strong oxidizing agent, that is acidified potassium dichromate. Second oxidation we can do by using copper, and the name of the reaction is dehydrogenation. The meaning of dehydrogenation, D means removal, okay, D means removal, and hydrogenation means hydrogen. So here removal of hydrogen will take place, means minus H2. This will be the process here, okay. So we have taken primary alcohol again. You can see CH2OH. This is my primary alcohol, copper, and the temperature requirement is 573 Kelvin. This is very important. The CH2OH group will convert into CHO group. Now see here what is happening. These are the 2 hydrogen. See, these 2 hydrogen are removed and this is your CHO. This is 1 molecule of hydrogen which is coming out. Okay, let us take example. CH3CH2OH. This is ethyl alcohol, copper along with 573 Kelvin temperature. Two hydrogens you just remove from here. I'm just showing you how this is happening, but always remember the primary alcohol on oxidation gives you aldehyde, and that on oxidation gives you carboxylic acid. Okay, so CH2OH group will always convert into CHO group. But for remembering, I'm just telling you that this two hydrogen you remove so that you get acetaldehyde and one molecule of hydrogen. Now same oxidation process if we do with secondary alcohol. So we have RCHOH. This is my secondary alcohol. This is the functional group for secondary alcohol. And I'm doing oxidation with copper along with 573 Kelvin temperature. The CHOH group will convert into CO group. That is, we are going to get ketone from the secondary alcohol with the liberation of one molecule of hydrogen. Take this example, CHOH. This is my isopropyl alcohol. On oxidation, you can just mention this is oxidation. Okay, along with copper and 573 Kelvin, we are getting acetone with the liberation of hydrogen. Okay, so here what is the summary we get? That is, if we have a 1 degree alcohol, on oxidation with a mild oxidizing agent, we get aldehyde. Okay, and this mild oxidizing agent can be PCC, pyridinium chlorochromate. If we have 2 degree alcohol, a pyridinium chlorochromate, or also we can use copper along with the 573, or I'm writing here only copper along with 573 Kelvin temperature. So primary alcohol on oxidation gives us aldehyde. On the other hand, if we have secondary alcohol, 2 degree alcohol, on oxidation it gives us ketone. Now the oxidation can be done with K2Cr2O7H+ or copper along with 573 Kelvin. So this is what we have done. The first preparation of aldehyde and ketone is by oxidation process, and oxidation can be done by using two different reagents. So now we come to the next preparation, and the next preparation is from hydrocarbons. And in hydrocarbons we are taking the first process, that is ozonolysis of alkenes. Now what is the meaning of ozonolysis? The meaning of lysis is splitting. Okay, lysis means splitting, or you can say breaking. It is breaking. Okay, and ozonolysis, ozone, so this is splitting with the help of ozone, is called as ozonolysis. So first we have taken ethene over here and we are reacting this ethene with ozone. First we are going to get an addition product, because we know unsaturated hydrocarbon will go for addition product. Okay, they perform addition reaction. So what will be the addition product? Just write it this way. This is your CH2 and this is your CH2. The two CH2 I have written. I just not written the double bond. Now one bond you just put it up like this and hold oxygen. Other bond will be holding the two oxygen like this. This is called as addition product, and the name of this product is ethylene ozonide. Okay. Now this will be followed by hydrolysis with the help of zinc, Zn2+ and H2O. So we are doing hydrolysis in presence of some zinc salt. Okay. What happens is, just break down this ozonide product now. Break down like this, from here and from here. So what is we are getting? See here we are getting CH2O, this side also CH2O. What is this CH2O? This CH2O is nothing but HCHO, formaldehyde. See, CH2O. So this is formaldehyde. We are getting two molecules of formaldehyde. Okay, so this is how we get aldehyde and ketone from ozonide, I mean reaction with ozone. Let us see for this one. This alkene is propene. So this reaction is called as ozonolysis of propene. So we are splitting up propene with the help of ozone. Okay, propene plus ozone. So we'll write the addition product, and the addition will take place across the double bond. Only across the double bond. This will remain as it is. So I'm writing CH3CH as it is. Now here the double bond will be broken. One oxygen is up and the other two oxygens are down. This will be followed by Zn2+ and H2O. Break this bond and you get CH3CHO this side, that is acetaldehyde, CH3CHO, and this side you get CH2O, which is again your HCHO. So what is the product? We get acetaldehyde, and aldehyde with one carbon atom, that is formaldehyde. Okay, very simple. Let's say, and this is called as propylene ozonide. This ozonide product is called as propylene ozonide. Okay. Let's say this reaction, I'll just show this reaction this side because there is no place, so I'll show it here. This is a branched propane. This is called as 1, 2 and 3. So this is 2-methyl propene. Again the ozone will get added across the double bond. So I'll write the rest of the thing CH3, and CH3 as it is. Now this double bond, one will go up, will hold one oxygen, this CH2 is as it is, and another will be like this. Another bond is like this, okay? You can write down this in a little nice manner, I mean this way also, just to represent the molecule in a proper manner. I can write down like these two CH3 like this, CH3 and CH3. Now the double bond which is holding the ozone molecule like this, and this is your CH2. Okay, now followed by hydrolysis with the help of zinc salt. So we write Zn2 plus here and H2O. This will break down. Here this side we are getting CH3COCH3. That is my acetone. CH3 C double bond O CH3 plus this side I am getting HCHO again, that is formaldehyde. So in this case you are getting acetone, that is one ketone, and formaldehyde, that is one aldehyde. Okay, so it depends on the type of alkene what you are going to get. You are going to get aldehyde, both different aldehydes, or same aldehyde, or one aldehyde, one ketone, or both ketone. That depends on the structure of the alkene. The next reaction is again from hydrocarbon, but now the reaction is by hydration of alkynes. Now what is meant by hydration? The meaning of hydration is hydroaddition. If you split it up, it is hydroaddition. That means your addition of water will be taking place. Hydration of alkynes. So this is my ethyne, the first member of alkyne series, and we are adding HOH here, but the reaction happens in presence of 40% H2SO4 and 1% HgSO4, mercuric sulfate and sulfuric acid. The reaction happens acidified hydrolysis, it is basically, but it happens in presence of HgSO4. This is important, okay? So water will take place, addition of water will take place, and that addition will take place as per Markovnikov rule. Now since this is a symmetrical alkyne, so it doesn't matter where the H is getting added and where the OH is getting added. So I'm just adding H and OH here. So H is added on this carbon, and then the triple bond will reduce to double bond, and then OH will get added over here, okay? So this is my product, and this is what you see. This is an alkene and this is an ol. This type of compound is called as enol, en plus ol, alkene en plus ol, enol. These enols are very unstable, you know, so they will tautomerize into, tautomerize is one type of isomerization. They will tautomerize into keto form. What will happen is this double bond, this will form a bond over here, and this bond will be broken. So basically it is this hydrogen will be shifted over here. It is called as 1,2,3 hydrogen shift. This is also called as 1,3 hydrogen shift. How come? This is hydrogen, wherever it is added, this is your first atom, this is the second, and this is the third. So hydrogen is shifting from here to this carbon. So you are getting CH3. This carbon was CH2. Now it is CH3 because hydrogen got added over here. This bond will be reduced to single bond, and then you will be getting CHO. This is a double bond here, and this is CH is already there. CH is already there, and this bond is converted into double bond. This is called as keto form. Okay, and this type of conversion is called as keto enol tautomerism. Okay, keto form is always stable than the enol form. So whenever you get ene and ol adjacent to each other, it is called as enol form, which will convert into the keto form. So in this case, we are getting acetaldehyde. This is our product, that is acetaldehyde. Okay. Same thing now we are going to do with an unsymmetrical alkyne. This is called as propyne. It is an alkyne with 3 carbon atoms, so it is propyne. We are adding water again in presence of 40% H2SO4 and 1% HgSO4. Addition of water will take place as per Markovnikov rule. Okay, and what is Markovnikov rule? The negative part of the reagent will get added to that carbon atom which is having less number of hydrogen. So now OH will get added to this carbon atom which is having less number of hydrogen. Always remember, we are going to see only those 2 carbon atoms which are having the triple bond. Don't see this carbon atom ever, okay? Because the addition always, the reaction always will take place wherever the functional group is there. Here the functional group is triple bond, okay? So the product we are getting is CH3COH. This triple bond will reduce to double bond and then we have CH. Now see again, this is an enol form, in and all adjacent to each other. So this is an enol form which is going to convert into tautomerization. This is tautomerism, okay? And always the keto form will be more. So while putting the arrow, I'll put this arrow bigger and this arrow smaller. This arrow is bigger. This is tautomerization, tautomerism. Okay, so this bond will come here and this bond will go here. Again, it is a 1,3 hydrogen shift. See, this is my first atom, this is second atom and this is third atom. So hydrogen from first atom is shifting to the third atom. Okay, so what is it? CH3, C double bond O, CH3. CH3, C double bond O, okay, I did not add the hydrogen over here. This will be 2 because this hydrogen gets added to this carbon. Now, OH get added to this carbon and hydrogen gets added to CH. So this CH will become CH2 and then 1,3 hydrogen shift. This hydrogen will shift over there. So you are getting CH3, COCH3. This is called as acetone or propanone. Now the next reaction is Friedel-Crafts acylation reaction. This is again my acyl chloride. And this is benzene. You know that benzene is a very highly electron rich substrate. So it will go for electrophilic substitution reaction. How it will go for electrophilic substitution reaction? AlCl3 is a Lewis acid. Means what? After forming bond with chlorine, you can see here aluminium is bonded with chlorine, but after forming the bond also aluminium has got only 6 electrons. It needs 8 electrons to complete its octet, but it has got only 6 electrons, which is called a 6-state condition. So aluminium is in want of 2 more electrons. So what it will do is, it will take this chlorine atom with the 2 electrons. This chlorine atom will be abstracted by aluminium with the 2 electrons and it will form AlCl4-. It will stabilize itself. So once chlorine has gone, this will become RCO+, which is a electrophile. Okay. Now this RCO+ electrophile will do what? This electron-rich benzene molecule will attack this and it will be forming, it will be giving rise to electrophilic substitution reaction. How? We are getting, this is my benzene molecule, these are the 2 bonds and here COR is getting attached. Okay, so this bond is attacking this carbon molecule. So one of the carbon is getting this molecule, the other carbon is now, it is shortage of bond, so it will be getting a positive charge. Now what will happen? This hydrogen, there is a hydrogen here, this hydrogen will form a bond over here. This is called as aromatization. How this hydrogen will be forming the bond? Because this AlCl4- will take this hydrogen, okay, and it will form HCl. Again it will lose the chlorine, it will leave the chlorine, it will again form AlCl3 because it is acting as a catalyst over here, and that hydrogen and this chlorine will give you HCl, and there will be a bond form ultimately. So you are going to get, the aromatization will be, again, it will be retained and you are getting this ketone plus HCl. Okay. So this is the entire mechanism of this reaction, but you don't have to show the entire thing. I just told you to make you understand. You just have to show this reaction like this. That is, this is my benzene. This is benzene. It is reacting with RCOCl in presence of anhydrous aluminium chloride. Remember, this anhydrous aluminium chloride is very important, because if you do not provide this anhydrous aluminium chloride, the reaction will not start, because that is only generating the electrophile over here. Okay, so you are getting COR. This is a aromatic ketone plus HCl will be liberated. Okay, same thing here. See, this is benzene and this is called as acetyl chloride. Friedel-Crafts acylation reaction. So the benzene ring will be containing COCH3 with the liberation of HCl. So for short, if you want to remember this, you can remember this like this. There is a hydrogen over here. This hydrogen and this chlorine will be coming out as a HCl, and COCH3 will get attached over there. This is called as, this compound is called as acetophenone. Okay, this is very well known as acetophenone. So now the next preparation is from alkyl cyanide. What is cyanide? Alkyl cyanide is RC triple bond N. This is called as alkyl cyanide. And the name of the reaction is Stiffen reaction. Again, there is a name reaction. Again, it is very important. So our substrate is alkyl cyanide, and we are reducing it in presence of SnCl to HCl. This is a reducing agent. SnCl to HCl will give rise to the production of nascent hydrogen. Okay. So what you are going to get is, just add the hydrogen over here, because it is reduction. Reduction means addition of hydrogen. So we are getting RCHNH. The two hydrogen are getting added over here, RCHNH, and this HCl will get added to it. Okay, so we are getting RCHNH HCl. This is called as imine hydrogen chloride. This bond, there will be a double bond here. Because there is an addition, the triple bond will reduce to double bond. There is a double bond, and this CHNH bond, CH double bond NH is called as imine. Okay, so imine hydrochloride we are getting. Now this imine hydrochloride will be hydrolyzed in presence of acid. Okay, so what will happen is, you are going to get double bond O here. So this entire thing will be coming out, and you are going to get RCH double bond O here. Rest of the products are like not important. This is our aldehyde. Okay, so we are getting aldehyde. So this is called a Stiffen reaction. The reagent for Stiffen reaction is SnHCl. Okay. Now see, this is acetonitrile. There are two carbon atoms, so acetonitrile, or you can also call it as methyl cyanide. If you call this as cyanide, then you have to just name one carbon atom, methyl cyanide, because in cyanide itself C is there. Or you can call it as acetonitrile. Okay, SnCl to HCl, which is providing two nascent hydrogen in presence of HCl. You are first going to get imine CH3, add one hydrogen over here, triple bond will reduce to double bond, add one hydrogen with nitrogen and dot HCl. Now this is imine hydrochloride. Okay, now this will be reacting further with H3O plus acidic hydrolysis. So you are going to get CH3CH double bond O. This is your acetaldehyde. Okay. Next reaction is by using diisobutyl aluminium hydride. This is also called as 𝐷𝐵𝐿H. 𝐷𝐵𝐿H. Diisobutyl aluminium hydride. This is also a reducing agent, which has a very specific function, that it reduces the cyanide into imine. Okay. So this is my cyanide. Diisobutyl aluminium hydride can also be written as like this, isobutyl di, so IBU2 and aluminium hydride. So this is providing two nascent hydrogen. This hydrogen will get added over here. You are getting imine first, and then you know how to hydrolyze the imine. So you are going to get RCHO. Okay, that is a aldehyde. This is aldehyde. So we have taken a particular example, methyl cyanide, or this is also called as acetonitrile. Okay, it's reacting with diagonal H, 2 hydrogen. First you add hydrogen over here, so CH3CH double bond NH. This is called as imine, and then you treat this with H3O plus. You're going to get CH3CHO. That is acetaldehyde. Okay, now the third preparation is from acyl chloride. Here we have first reaction, that is Rosen-Mundt reaction. It's a name reaction and it is only applicable for the preparation of aldehyde, remember. Okay, here we are going to use an acyl chloride as our substrate. Acyl chloride is what? COCl group is called as oil chloride. Okay, so plus hydrogen. So basically it is a hydrogenation process, but the hydrogenation takes place in presence of PDBaSO4. Okay, so it is a controlled hydrogenation basically. Here this BaSO4 is a this is a catalyst poisoning. Here hydrogen and PD is a catalyst, because hydrogen, you know that it gets absorbed on the palladium metal and gives a larger surface area for the reaction to happen. BaSO4 is a catalyst poison. It will be acting as a catalyst poison because otherwise this will reduce to primary alcohol. So because we know that this aldehyde reduces to primary alcohol. To stop that particular conversion, because we want to stop the reaction in aldehyde level, so we are using BaSO4, which will be acting as a catalyst poison. Okay, and it will not allow the aldehyde to further reduce into primary alcohol. So we are taking acyl chloride and hydrogenation in presence of PDBaSO4. We are getting aldehyde. The COCl will convert into CHO group with the liberation of HCl. Very important, whenever you see hydrogen and PDBaSO4, you understand it is Rosen-Mundt reaction and it is a preparation of aldehyde. So there aldehyde will be forming. So whatever number of carbon atom you have here, same number of carbon atoms aldehyde you are going to get in the product. So here we are using acetyl chloride and it is converted into acetaldehyde. Okay, so this is your Rosen-Mundt reaction. Very important. Next reaction is from Grignard reagent and it is applicable only for ketones. Okay, so here we are taking Grignard reagent RMgX and CdCl2 is a salt, cadmium chloride. Okay, so first of all we are getting R2CD, which is called as dialkyl cadmium, and magnesium. See, basically this is plus and this is minus here, and this is minus and this is plus here. So this plus will get added to the minus sign. So you get, here we are taking two molecules, so you get R2CD, which is called as dialkyl cadmium, and MgCl and X, 2MgX and Cl. Okay, so this is my reagent over here. We are having this substrate, that is oil chloride. This is again acetyl chloride, acyl chloride. This is acyl chloride, and now this will be reacting with R2CD, which is my dialkyl cadmium, which is formed in the previous reaction. Okay, so basically this is the reagent and this is the substrate. What is happening? See, this R2 CdCl2 will come out. CdCl2 will come out. I have taken Cd and here 2Cl. So CdCl2 will come out and R2 will get added over here. So we get RCOR. See, this is, if this is R2, then it has to be R2 over here. So okay, no, sorry, this is R2 means there are two R. Sorry, this is not R2, this is 2, there are two R actually. So it is R plus CdCl2. Yeah, so this 2R is getting, this Cl is coming out and 2R is getting attached over here. So we are getting RCOR plus CdCl2. Okay. Just we'll see this reaction. CH3MgBr plus CdCl2. First of all, make it 2 and we'll get dimethyl CH3 whole twice Cd. This is called as dimethyl cadmium, which is my reagent, plus another product is what? MgBr and Cl. This will be 2 molecules. Now this will be acting with acyl chloride. Okay, so I'll be taking CH3 whole twice Cd plus CH3COCl. This is my substrate, which is called as acetyl chloride. Okay, and this is your dimethyl cadmium. What will happen? CdCl2 will come out. So make it 2. So you're getting 2CH3, C double bond O, and Cl is coming out 2Cl. Instead of that, 2CH3 will come here, and this will be CdCl2. This is called as acetone. I hope you understood. Same thing we'll see here. We'll do the reaction with C6H5CH2MgBr plus CdCl2. So here C6H5CH2, this is the alkyl group. We'll take 2 molecules of it. So it will give you C6H5CH2 whole twice Cd plus MgBrCl. Now this is my reagent. So I'll take the reagent here, C6H5CH2 whole twice Cd plus acyl chloride. I'm taking CH3CH2COCl. This is your propanoyl chloride, 3 carbon atoms. So propanoyl chloride. Okay. Now this CdCl2 will come out. You take 2 molecules of this, will be 2CH3CH2C double bond O. Okay, and then this will get added CH2C6H5 plus the other product is CdCl2. Okay, so this is how we can prepare ketone. Here in this case we are getting ketone from dialkyl cadmium. That's the reagent. Okay, and dialkyl cadmium, how we are preparing? From Grignard reagent and CdCl2. First we are getting dialkyl cadmium, and then that is reacting with the acyl chloride to give you ketone. The next reaction is with Grignard reagent. We are using the same substrate, that is nitrile, and reacting with Grignard reagent, but this is only for ketone, preparation of ketone. Grignard reagent, whenever you are reacting anything with Grignard reagent, always we have to use dry ether, because Grignard reagent cannot work in water medium, because it is very reactive, then it will convert into alkane. It will give rise to alkane. So dry ether. So what is happening? See, this is plus and this is minus, and this is minus, this is plus. So this minus will get attached here and the plus will get attached here. So you're going to get RC, this is R dash, double bond N, MgX. This is minus, this is plus. Okay. Once this R gets attached to the carbon, this bond is broken, and that is how it is getting the minus charge. And to balance the minus charge, MgX is coming. Now you just hydrolyze it, acidic hydrolysis. This entire group will convert into oxygen, double bond oxygen. So this is your ketone. This is specifically for the preparation of ketone. Let's say this is acetonitrile, CH3MgBr. So CH3 will get attached to this carbon atom and get attaching over here. Then this is double bond N, MgX. Now this will go for acidic hydrolysis. The entire this group will convert into O. So double bond O, CH3. You are getting acetone from here. Okay. This is cyanide. We can call it as benzene cyanide. And this is phenyl magnesium bromide. Phenyl magnesium bromide. So this phenyl group will get attached. So this is C. There is one benzene ring over here. I will draw it like this. Another benzene ring getting attached. Okay, and then this double bond, and this will be NMgBr. And then this followed by acidic hydrolysis. So this will be double bonded O. So this is, I can write it like this, PH, C double bond O, PH. This is called as benzophenone. Benzophenone. PH, C, PH. If you want to draw the structure, it is like this. this is your benzophenone. This is the structure of benzophenone. So in today's video we have covered 3 preparation methods, and some of them were exclusively for the preparation of aldehyde and some of them were exclusively for the preparation of ketone, and some methods were common to both aldehyde and ketone. In the next video we are going to start with preparation number 4, that is from ester. There are not many preparation methods, so I have divided this video into 2 parts. In the next video also we are going to start from here. Thank you so much. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. Thank you. Stay tuned.